before the hypothesis test. Okay? I think it would be better for you to prepare the final. So maybe I'm going to give you a few questions from the previous topics. Okay? Maybe the ratio may be 30% or 70% or 40% or 60%. Okay? It may be better for you to see review the prepare for the final. The details about the final practice each 5, I will make an announcement maybe tomorrow after completing the actual final exams. Okay, and maybe better for me to prepare the final quiz. Okay, I'm going to try make the final quiz similar to the final test. Okay, and because I have to wait until this Friday. Anyway, I'm going to definitely say that the final quiz, it's a portion of they are not only for the hypothesis test. Okay? It includes the previous topics. Okay, so you can consider the final quiz as a simulation of a final test. Okay, let's go to the question. And also, I uploaded the practice test 2, right? Okay. But I found that there are some typos or some questions are double because all instructors participate in making the final practice quizzes. And I found some typos and mistakes in this final this practice test in version 1. I will look at that one. Also, to prepare the final, personally, I think this week's practice questions and also we covered all the practice questions. Okay? Then I think that's enough for the hypothesis test. Right? But for the previous topics, you need to review all the. I suggest that only 2 exams, right? Exam 1, exam 2. In addition to that, we have practice test for exam 1 and practice test exam 2, right? Yeah, enough to prepare the previous topics. Okay? And also, there is a homework 13. There is 37 points. It's a really huge point. And then you can, after reviewing all the topics, and then try to solve the homework 13. Then you can check for which topics you are missing about the previous topics. Is there any question? Okay, let's go to the question. So, as I mentioned, you finished the course evaluation, right? So after looking at the percentages of your participation in the course evaluation, I'm going to give the points to the midterm 2, right? And for the final, I need to wait the instructions special meeting, and then there may be some curves for the final. Okay, so that means you have 2 chances to raising up your scores, right? In addition to that, the lowest score of the quizzes will be dropped, and the lowest scores of attendance, lowest scores of the homework also will be dropped. Okay, so then you have more chances to raise your scores up. So don't give up. Don't give up. Okay, let's look at the question. A pharmaceutical company claims that its new pain relief medication has an average effective duration of 8 hours. This is the pharmaceutical company's claim. And a health researcher wants to test this claim and hypothesize that the true average duration differs from what the company claims. Okay? From these 2 statements, we need to identify what the random variable, what the parameter, what the hypothesis. What is the random variable here? the effectiveness duration, right? The effectiveness duration that is the random variable. What is the parameter here? Okay, whenever you are asked what the parameter is, you just think about the mean and proportion. Okay, those two parameters are what we covered in these courses. So when you are asked what is the parameter of interest, then what is the mean, what is the proportion? Not simple, okay? The population mean, population proportion. Then what is the parameter here?
Population mean of 8 hours.
That is a value of a hypothesis. That is a claim, right? Yeah, that is correct. But you said just a specific number. There is a possible value for the parameter. Okay, the pharmaceutical company that parameter is A, right? But the health research said that is less than or that differs from A. Okay, then what is the parameter here then? What is the value of A?
It's the average or mean.
Yes. Average effective duration. That's the parameter. A is a specific value of that. Right? We set the value as A on the null hypothesis. But what is the alternative hypothesis then? The researchers want to test what? That is not A. Equal from the pharmaceutical company. That means mu is not equal the value which the pharmaceutical company claims. Okay, that's the alternative hypothesis. So that means is the alternative hypothesis one side or two side? Two sides. Right? Different from means two sides. Why I emphasize the direction of alternative hypothesis? Because it really gives what effect on what? Effect on computing the p-value. Okay, so H null is, yeah, so A is the correct. Okay, let's look at the remaining thing. The standard deviation of the effective duration is known to be 1.5. So it is said that sigma is known by 1.5. Suppose if the population standard deviation is known to us, then what distribution cannot be used here? T. Because we know the standard population standard deviation, there is no possibility of using T distribution. Okay? See, sigma is 1.5. The researcher conduct a study with a sample of 50 patients. So sample size that is 50. And find the average effective duration that is 7.8. What is this 7.8? How do we get this one? How do we get this 7.5? Where do we get this 7.8? From the sample. Yes. So what is the symbol for this one?
X bar.
X bar, yeah, X bar. X bar is 7.8. Okay. Then assume a normal distribution of effective duration and conduct the hypothesis at the 5% sigma. Okay, then what is the alpha here? 5? 2.5? Alpha. What is the alpha?
The 1 minus the significance level.
0.05.
1 minus significance level.
105.
What is the symbol for the significance level? Alpha. So alpha is here 0.5. Right? Alpha is 0.5. Now let's look at the question 2 then. Given the standard deviation 1.5 sigma, sample size n equal 50, sample mean x bar is 5.8. Calculate the test statistic. Okay, what is the test statistic here? X bar minus mu null. Okay, we have to use the value of mu on the H null. And then because sigma is known, sigma over square root n. Okay, that is, we can use this. It may be better square root n x bar minus mu naught and sigma. Okay? Why? Because it is better to write it this way to compute because you are going to use the calculator, right? Then it is better to use than this one. Okay, how much is that? Sample size 50, x bar is bar, how much x bar? 7.8, right? 7.8 minus, what is the value mu naught? Mu naught is
8.
8. Mu naught means the value of mu on the h naught, right? That is 8. And then what is the standard deviation? Published standard deviation is 1.5. How much is it? Is it positive or negative? Negative, right? So cancel this 3 one. Which one is correct? This one, this one.
Negative 0.9.
Yes, negative 0.9. Okay. Okay, then based on the test statistics and the 5% significance level, what's the appropriate conclusion to this hypothesis? In order to draw the conclusion, what should we compute? P-value. Let's look at the p-value here. In order to compute the p-value, what hypothesis is important to us? HA, because we need to look at the direction. So p-value is probability of test statistic. In this case, we use Z. G is less than or greater than, or equal to, not equal. Because the two sides, that means our p-value should be sum of the two tail areas, right? In our case, because two sides means the p-value should be the sum of two tail areas. But our computed test step value is negative one. So where's the location of negative point 0.94? Left one or right one? Left one. This is negative 0.94. Okay? So because the G distribution is symmetric about 0, the sum of these two tail areas is equal to what? Twice of less than 9. Does it make sense? Right? If your test status value is 0.94, then you are going to take this area and then twice. Okay? So how much is this one? Let's look at negative 0.94. Okay? Negative 0.94, negative 0.94. Where is it? Where is it? Okay. Negative 0.94, 0, 1, 2, 3, 4, this one. Okay? So 1736. That is 1736. That is 2 times, how much was that? 1736? Yes. That is almost 0.3472, right? Is it small value or large value?
Large.
It's really huge large value. Okay? Because it is greater than 0.5. Okay, so what is our conclusion then? P-value is greater than alpha. So what's our conclusion?
Fail to reject H naught.
Reject H naught or fail to reject H naught?
Fail to reject.
Fail to reject H naught. Fail to reject H naught. Okay? You need to write down this one on your formulation, right? Maybe I heard that the other instructor said that we allow you to bring 3 pages of formula sheet. Okay, I will confirm that. Okay? If you can bring 3 pages of formula sheet, then you can write down a lot of things, right? But not the question itself, okay? I will make a confirm that. Too many good news, right? That means you have a lot of chance to raise your scores. Okay. So let's look at it. So we fail to reject H naught. So what is our conclusion? Fail to reject H naught, fail to reject it. So we need to choose between B and D. What does mean fail to reject H naught? Means we keep H naught, right? The data does not show strong evidence. What? Strong evidence in favor of HA, right? So the data do not provide sufficient evidence that the average effectiveness is different from A. This is HA. Okay. How about why then D is equal? The data provides sufficient evidence that the average effectiveness duration is exactly. Why D is incorrect? Because the reason we do this experiment to see whether the alternative hypothesis is really meaningful or not. Okay. So far, up to before, so prior to the experiment, the pharmaceutical claim has been true, right? But because of our new, who was the guy? Yeah. Because of these health researchers, they doubt about the pharmaceuticals, the company's claim, right? So the reason why we do this test is to see whether the researchers' hypothesis, in other words, alternative hypothesis is meaningful or not, right? Because of that, B is correct, not D. Okay? Now let's look at C. Is there anyone who can read this one? Statement by statement. Statement by statement. You can read it.
A researcher is interested in testing theory that the average height of professional soccer players is less than 75 inches.
Okay, stop here. Then what is the parameter? You can answer it. What's the parameter?
Average height of all soccer players.
Yes, average height of professional soccer player. That's the, so what symbol is good to be? What symbol? Mu, right? Mu. Then less than 7 inches. Then is it alternative hypothesis or no hypothesis?
That's alternate.
Alternative hypothesis. HA should be mu is less than 75. This is alternative hypothesis. They want to see whether this hypothesis is meaningful or not. Let's okay. Can you read that? Thank you.
List of all professional soccer players. He takes a simple random sample of size 31 players.
Yes, it's the sample size is 31. That is n. Then
His sample mean is x bar equals 72.9 inches. And
and
small conditions are met, and the p-value equals 0.15.
okay. P-value is 0.05. Is it big value or small value? When I ask whether the p-value is big or not, that means the threshold value is 0.01 or 0.05. If the p-value is larger than 0.05, then yeah, it's really big value. If the p-value is less than 0.01, then it's a small value, right? Usually the alpha sequence level are commonly used one for 0.05 or 0.01. Okay, which of the following is the best interpretation of the p-value? At this question, they are asking the meaning of p-value. What is the definition of p-value? P-value is it number or action? Is p-value number or action? Number. It's a probability that what? The test statistic is at least as blank as the observed one. Under blank. What is the first blank? What? Extreme, yes. Extreme. As extreme. And what is the second blank? Under which hypothesis is the p-value calculated? H0 or HA? H? You did not say that. H, no, or HA? Which one? Just the H? H0. Okay? And the H0, you have to compute. Okay? So, the meaning of extreme depends on alternative hypothesis. Okay? It has the same direction as the alternative hypothesis. In this case, our alternative hypothesis direction is lower than, okay, upper direction, smaller than something. That means our test status in this case x bar is less than or equal to, what is our observed value for this x bar? It's 72.9, not 75, okay? But what is the null hypothesis? Mu is 75. Okay, we have to compute this one. Okay? But in this case, in this question, they did not want us to, they don't want us to compute this value, but interpret the minimum. So we need to choose this one from these 5 options. Which one is the correct explanation for this one? I'll give you 1 minute, okay? And then I'm gonna ask some specific person to answer right answers, okay? Please read the 5 options and then find one, explain this please. Okay, I will look at the rosters. This is Korean style. In my country, we look at the roster and pick some person and ask you. This is 504, right? Okay, I got it. Okay, I'm going to ask a person what is their good answer is. Okay. Is Michael Chema? Who is Michael Chema? Who is Michael Chema? He does not. Can you hear? No? No one? You? Okay. Okay. Can you pick the options? Which one is correct one? Just to try. Any volunteer? Okay.
Is it B?
B?
Yes.
Okay, let's look at that. P value tell us that if the true average height of professional soccer player less than 75, if that is less than 75 inches, is it H null or HA? Then I said that it should be equal to H null. That means you are not going to make an error in the findings. Okay. Good try. So B is incorrect because it said if that is less than, that means alternative hypothesis is true. That means we need to choose the if H null is true. And what is the H null then? So which option? A. Yes. Let's look at the true average height of the proportional soccer player is 75 inches. This is H null is true. Then next we need to choose this explanation. Then the probability that randomly selecting a sample of 31 players with sample mean height of 72.9 inches or less, equal or less, and at least exceed. That means equal or less. This less should be equal to the direction of HA, right? 72.9 is what? That is 0.15, so 15 out of 10. So correct answer should be A. Okay? Now let's look at 5. Okay? Oh, it's interesting. Okay, then let's go to the dichotic material may trade. Can you read the question and then find the answers?
A biologist is studying the impact of a certain pollutant on plants.
Yes, here, the researcher's interest is to study there is the impact of a certain pollutant on plant growth. That is his interest, right? And then,
The null hypothesis is that the pollutant has no effect on the growth rate. In an experiment, the biologist treats 100 plants with the pollutant and compares their average growth rate to the known average growth rate of untreated plants. The known average growth rate of untreated plants is 5 centimeters per week, and the standard deviation is 0.5 centimeters per week. The average growth rate of the treated plants is found to be 4.8 centimeters per week. The biologist conducts hypothesis tests at the 5% significance level and finds a p-value of 0.04.
what is the appropriate conclusion, right? So in order to get the conclusion, we just compare p-value and alpha. What is the alpha here? 0.05. Okay. The significance level, that is alpha. Alpha is the probability of type 1 error, and p-value is 0.04. Then what is our conclusion?
Reject.
Reject H naught. Reject H naught, not reject A, HA. Okay, reject H naught. Then A and C. You need to choose between A and C. Which one is correct? That means we need to look at HA. Okay, so the data shows us meaningful evidence, significant evidence that HA is okay, right?
B. Wait,
Oh,
no, A.
rejected, yeah, rejected. HA is okay. What is
I think
HA?
it's A, isn't it?
The pollutant affect the plant growth or the pollutant decrease the plant growth. Which is correct? A. Okay. So in this case, they say that they want to see whether there is an impact or what, right? That means what type of alternative hypothesis? Is it one-sided or two-sided?
Two-sided.
What? Two-sided. It should be two-sided. Okay. Okay. Let's look at number 6. Colin Hamad. Colin Hamad. Who is Colin Hamad? He's not here? Okay. Can you read this one?
The mean speed of internet in your apartment is usually 35
Megabyte, yes.
megabytes.
Megabyte. It's a computer unit.
The internet provider suddenly charge you more for a lot of lots.
You may have experience like this one, right? Because in College Station, suddenly this thing monopoly, right? Okay, next step. Next step.
They claim the mean speed of your internet connection to be more than 35 megabytes.
Yes, here they claim suddenly claim that the mean speed of their internet connection to be more than 35 megabytes, right? That means suddenly there's someone saying that the suddenly speed is less than 35, but suddenly the speed is faster than 35, right?
You are skeptical, so you tracked your daily internet speed for the last 30 days. Your speed data yields the sample mean 36.2 and the sample standard deviation 4.32.
Yes, so what is the 30 here then? And the sample size. Then this is X bar. This is, what is this 4.32? That is sigma or S? S. That's the sample standard deviation. Okay, so what is the parameter here? Parameter, the mean speed of internet, suddenly internet, right? So, in this case, you need to ignore one. You need to delete the first two options, right? Why? Why you delete A and B first? Because? Yes, the hypothesis should be written in terms of parameter, not statistic. Okay? So, it's wrong. We need to choose between C and B. Which one is correct? C, because it said that HA is what? When the mu is greater than 35. This is what the persons want to see, okay, based on the data. Okay. After choosing the upward test, what would be your conclusion alpha equals 0.5? Alpha equals 0.5. Okay? In order to get to the conclusion, what should you compute? G score? G statistics. Before okay. I said that. In order to get to the conclusion, what should you compute?
Are we not computing the p-value?
P-value. Yeah? So in order to compute the p-value, you need to identify what's the distribution of the test statistic. Okay? So in this case, let's look at the p-value. P-value is what? Probability, because test statistic x bar is greater than or equal to or less than or equal to. Which is correct? Greater than or equal to, because our alternative is greater than. Then what is the observed value of x bar? 36.2. What should be the mean mu? 35. Okay? So let's compute this. That is probability. I'm going to write down G. Okay, here I write down G. Okay? Then I have to 36.2 minus 35. Divide by, in this case, I have to use S over M. What is S? 4.32, and the standard deviation is 4. Okay, sample size is 30. Okay, how much is this one? How much is this one? Can you compute this one? Square root of 30 times 1.2 divided by 4.30. How much is this? Please help me.
1.52.
1.5. Okay, so our p-value should be probability G is greater than 1.52. Okay, this is greater than. So in the G table, it should be on the right hand part. Okay, 1.52. In order to get this area, we have to, because the G table is only this part, right? So there are two ways to get this one. This is 1 minus probability G is less than 1.52, right? So you are going to compute this one and then just take away this part. It may be as or because G distribution is symmetric about 0. So this area is equal to what? Negative 1.5. This is equal. This area is equal to this area, right? So this is equal to probability G is less than negative 1.52. Then you don't have to do subtraction, right? Let's look at this one. Understand? Okay, so negative 1.52. Negative 1.52. Where is it? Negative 1.52. 5.52. 1, 2, yeah. Point this one. Negative 1.5, 0, 1, 2. So this one. 0.064. Okay, then our p-value is greater than alpha, right? Our p-value is greater than alpha. So we fail to reject H. Okay, so which one is it? C or D? Then at the sequence conclude that certain link was correct or certain link was wrong. Which one is correct? Conclude that certain link was correct or wrong. We failed to reject H now. Conclude certain link. What was the certain link's claim? Their speed is faster than 35. Fail to reject H null means what? We have to keep H null.
So
Right? That means certain claim is wrong.
So wrong.
Right? Number A, question A is wrong. Okay? In which of the following situations would it not be appropriate to use a t-test? I think the person who made this question was not about the t distribution.
Which one?
You know it, right?
Oh, yeah.
What is the condition when you apply the t distribution? Normal population and unknown standard deviation. Okay? Other than that, you cannot use t distribution. You just use g distribution. Let's look at number A. Nice. Suppose we do a hypothesis for the population mean mu with the unknown population standard deviation sigma on a sample size of 100. Here is the question. See, the number 9 is also incorrect. Why? See, the t distribution. When I define the t distribution, did I give you any condition about the sample size? No matter what the sample size is, if the population is normal and standard is unknown, then we just have exact t distribution. In that case, when you use the t distribution, the sample size does not matter. Okay? So also this question is incorrect. So in this case, we have to say that the population, there is some hint about the population follows normal distribution, right? So such as, when I take a random sample from this population, that distribution, the distribution of this random sample looks like this, then they show histogram of samples, right? If the histograms look like normal, then we can say that our population is also normal. Why? Because the random sample means what? That is really well representative of the whole population. So if the random sample, a sample shows a distribution normal-like, that means we can guess our population is also normal distribution, right? That is also a hint, hint of population following normal distribution. In any case, you have to have the population follows normal in order to apply the t distribution. Anyway, suppose we have the conditions for the t distribution are met, and then what is the degree of freedom here? It's easy, right? Because sample size 100, degree of freedom is n-1, 99. For the two-sided test, how do we calculate the p-value? If this is the t distribution, then we are going to use the t distribution degree of freedom n-1, the sample size t. For the two-sided t test, the p-value should be addition of the sum of these two tail parts, right? Okay. Then I'm going to ask you, the value here is positive value or negative value? Negative. How about this one? Positive. Let's look at that. Just we take one area and then we are going to take twice of that, right? So then if I take this one, 2 times twice of probability t distribution with degree freedom n-1 is less than this value. Okay? That's I'm going to write down this A. Or 2 times of probability t n-1 is greater than this value. B. Okay? Then this A should be negative 1. B should be positive 1. Then is this correct or not? Is this correct? Why? This is the distribution. See, you see the absolute value of this is always positive. That means this is less than positive. Is this correct? No. Then it should be here, like this one. Right? So this is type. You understand? Absolute t is always positive value. So that means it should be here. Okay, so this may be 2 times probability degree of n-1 is greater than t, or twice of probability t n-1 is less than negative. Right? If no, this is the correct. But in the computer output, when you look at the computer output, in order to represent the p-values, there is saying that probability t greater than t or less than t, or probability absolute t, something like that, right? But in that case, this represents what? Represent the two sides. Anyway, so for the two-sided t-test, the p-value should be the sum of two tail parts, right? So the left one is the value on this horizontal line should be negative one. The right side it should be always positive one. But you know, see, the absolute value is always positive. That means it should be greater than absolute t. Okay? Now let's look at 11. Oh, yes. Oh, fortunately we covered that one. We covered that one. Okay, at Monday, right? 11, 12, 13. Okay, let's look at the 14. When I explained the 13 and 14, I said that alternative is important. See, in 13, see, because the p-value is the left tail part. Okay, p-value should be this area. Why? The alternative is less than something. Okay? In this case, p-value is greater than something, HA is greater than something, so the p-value should be the right tail area. Right? That means in this case, the lesser the observed value is, the smaller the p-value. But in this case, the bigger this value, the corresponding error is small. The p-value is small. So in this case, the bigger values. Right? For 13 and 14 are just the opposite. I covered this on 15 also. 16, 18, 9, I did that. So I'm going to look at 17 now. So what is the above test statistic? In this case, we are looking at the sample proportion, right? So when we treat the sample proportion, can we use T distribution? No, we always use G. So T go up. Okay? Then when can we use the G distribution? When we have sample distribution about PN, we need to check whether the NP and N times 1 minus P is greater than 10, those numbers. Okay? So B is the correct one. 19, 20. Okay. 20. For a certain statistical test, conducted at a 1% serious level, that means alpha equals 0.1, and the power of the test was determined to be 0.95. So what is the signal for the power of the test? Yeah, 1 minus beta. That's correct. 1 minus beta. That is 0.94. Okay, then what is beta then? 1 minus 0.94. That is 0.06. This is typo, right? It should be 0.6. Okay? Alpha equals 0.01 and beta should be 0.6. Okay? What does it mean our result is statistically significant? That means we reject H star. When can we reject H star? When p-value is less than alpha. So p-value is, usually we do not use equal, but p-value is less than the significance level. In that case, we reject H star. Right? Reject H star means the result is significant, statistically significant. Those three words are the same. P-value is less than alpha, reject H star, the result is statistically meaningful. They are the same. Okay. Let's look at 22. A credit union has received several customers' complaints for the long waiting time before their calls were answered. The average time a customer will wait before the call is answered, 15 minutes. They have to wait 15 minutes. So the credit union increased the number of customers represented and conduct a hypothesis test whether the customer's waiting time is decreased with secrecy level 0.5. Okay, H no, not decreased. HA, the waiting time is decreased. If we set use mu as the average waiting time, it should be 15. HA is used less than 15. Okay, what is the type 1 error? Type 1 error means what? We reject H null when H null is true. Okay, even the H null is we just mistake of rejecting H null. What does it mean? Rejecting H null means we say that the average waiting time has decreased even though it is not decreased. Right? So choose that. What is the correct one? Conclude that the average waiting time has not decreased. No. Conclude the average time has decreased. When actually it has decreased. No. Then actually it has not decreased, but the average time has decreased. This one is correct. Right, type 1. B. Choice 3. What's the probability that test will result in type 1 error? What is the probability of type 1 error? That is equal to alpha. 0.5, right? Last question. Medical researchers now believe there may be a link between baldness and heart attack in men. Okay? So the hypothesis H no is there's no link. Okay, HA is there is a link. Okay, that is the researcher's hypothesis. What would constitute a type 2 error? What is type 2 error? We fail to reject H null even though H null is false.
Yeah.
That means H is true. That means what? Even though there is a link between those two things, we say there's no link. What's the one? The study finds no link between RA. In reality, there's no link. In reality, there should be H1. In reality, no link. In reality, link, right? No link. C and D. The conclusion was that fail to reject H1. That means we say that there's no link. The Bible no link. So C is the perfect. Okay? So please review all this one, okay? If you are not feel comfortable, you don't feel comfortable, just